All right, so in this video I'm going to be showing you guys how to use a Hall effect sensor. A Hall effect sensor is this guy right here. It's thin, and the way that it works is it can detect the presence of a magnet. The pole matters, so which way you put the magnet on matters. And I've got a one here in this breadboard. So you can see it right there. See how it's tapered. The pin out on the Hall effect sensor. So first of all, why would you want to use a Hall effect sensor? Helps you to detect if something is closed or open or in a particular position. So you can slap a magnet on, put a sensor inside of a cabinet, put a magnet sticking out on a door. The magnet's under the sensor when the door is closed. When the door gets opened, it pulls the magnet away and you can detect that the door is open. So it can help you detect the positions of things. So here is what the pin out of the Hall effect sensor looks like. The leftmost pin with the tapered side facing forward is 3.3 volts or 5 volts, so, or VCC as some people say. And then ground is the center pin, and then the rightmost pin is your output pin. So show you guys how I've got this set up. So on my breadboard I have 3 LEDs, a green, which is tucked back there, so a green, a yellow, and a red. You can see I've got all of the cathodes connected to a single resistor going to ground. And then I've got that orange, the purplish or red, and the green going to the 3 different output pins of the Pico. And then I have my blue wire there on the leftmost pin that's going to 3.3 volts. The black is going to ground. And then that green on the Hall effect sensor is going over to pin 3 here. Pin 3 you can see on my Hall effect sensor. I'm using my Pico Zero library because it makes it very easy. And I just set these up. If I jump down here, you can see I can turn on, let's turn on my green LED on, and it should turn on my green LED. There it did. And then obviously I can turn that off as well, toggle it off. All right, so what we're gonna do is we imported a digital input device. This is kind of like a button or a switch. It's just a generic form. We're going to have it pulling up is true. So this is important to include. This means that whenever the output is on, it's going to respond high. And then we're going to have the active state, and I've got it set to false. All right. So run my code. And when I run my code, I'm going to rotate this a little bit so I can come in here with the magnet. And the polarity matters, so I've got to see if I've got it going the right direction, and I don't. So it's not turning on, so I'm flipping the magnet around the other way so that the other pole gets close. And you can see whenever the magnet gets near the Hall effect sensor, it will turn on the green LED. And that's what I have here in the code. It says Hall effect sensor when activated. So when it's getting pulled high, then it is going to be on. So the active state is set to false, meaning that it's normally off. And then whenever the magnet gets near, it turns on. I want to show you that if I take, I'm going to zoom out so you guys can see what I'm doing here. So you can see whenever I get the magnet close, it turns on. If I move the magnet around, so I didn't rotate it. So if this, let's say that this is the north pole pointing at it. So if I move the north away, so the south pole is pointing at this side and get it close, then it will turn on. So let me check. Yeah, there we go. And get that close. There we go. And you can see that it turned on. So get the south pole close to the back side. So if the north on this side turns it on, then the south on this side also turns it on. So I just wanted you to see that that is how it works. Now I'm going to come up here to my code and I'm just going to change this from active state from false to true. So this means that it's always going to be active until it's toggled. So which means that our light, once this runs, should turn on. There, okay. So it is on, and then whenever I get the magnet close, it is going to, sorry, and that's a magnetic, it's going to turn off. So you can see active state is on, and then I get the magnet close, and it turns off. So depending on what you want to do with your setup, you can have a Hall effect sensor that is detecting, let's say you wanted a light to turn on in a cabinet. You 3D print a piece of plastic, have it pause at a particular layer, embed a magnet, have it print over the top so it's all sealed up. You've got screw holes in the little 3D part you printed, screw it to the door, and now whenever the magnet is going to be right over the Hall effect sensor inside the cabinet, you got 3 wires coming out for power, ground, and signal. Going to a microcontroller that's connected to a bunch of LEDs, and then whenever the door gets opened, it detects the door is open and it turns on the light. That could be a way you do it. You could use a simple switch to do a setup like that, and then just have it so that whenever the door is open, the switch closes the connection and all the lights turn on. But if you use a Hall effect sensor, you could do this with a switch as well, then and a microcontroller, then you could have the lights dim, like so they can fade on or they can fade down. And that's something you can do pretty easily with a microcontroller. That's a lot harder to do with a circuit. You can do it with resistors and capacitors and have it fade up. So there are ways, but this is the easiest way to do it is with a microcontroller. All right, so hopefully that's helpful for you to be able to see. I'll have all of this code linked in a gist so that you can copy and paste it. Obviously, you could even toggle things on, toggle things off with doing a while true loop and doing if, and instead of Hall effect sensor, you could do Hall effect sensor dot is activated, which responds with a true. So that would be true. So if Hall effect sensor is activated, and then under that if statement, you could do a bunch of things instead of just a simple turning on and turning off. All right, hopefully that's helpful.